All right, so last class, 4.1, we did multiplying and dividing, okay? We are now going to be dealing with adding and subtracting, okay? And the reason we didn't do this first was because this is just a little bit more difficult, in my opinion, than multiplication and division are, okay? But it's not too bad, but we'll go ahead and get started. If we look, when we are adding and subtracting, the first thing we've got to do is rewrite the problem using a common denominator. Once you have a common denominator, you're going to combine the numerators and keep the common denominator the same. And then last but not least, what we always do is we simplify. So if we're able to factor or cross anything off, that's when we're going to do that. Okay? I don't want you to write this right now, but I just kind of want to backtrack to like middle school math here. Okay, we have added and subtracted rationals before. Okay, and we use this exact same method. Okay, but I just want to show you it. All right? So if I had, for instance, 1/3 plus, let's say, 4/3. Do those have the same denominator? Yes. Okay, so I can keep that same denominator, right? And I would just add those two numerators together. So what is 1 plus 4? 5. Awesome. Okay? But let's say, for instance, I had something a little bit different. Let's say I had 1/4 plus 4/3. Do those have the same denominator? No. But what is a number that 4 and 3 will both go into? 12. Okay? And 12 is the smallest number they'll both go into, correct? Okay. Could I pick a bigger number that they'll both go into? Yes, but that's just going to be more work in the end because I'll have to simplify further, right? Okay, so this is going to work the exact same way. You've got to make sure, though, that you have a number that they will both go into, and preferably the smallest number, all right? Same thing, though, with the variables. That's also going to play in. So let's say, for instance, I had 1/4x and 4/3x squared. What would be my common denominator then? 12x squared, right? Because x will go into x squared and x squared will go into x squared. You with me? Okay, so make sure you have a number and a variable that absorbs everything. All right, so that's how this is going to work. So we're going to start off with number 1 here. First thing we check, are my denominators the same? Yes. So that's easy. Okay, they've done most of the work for me. What do I have to do? Just add the numerators. Okay, so keep the bottom and add the top. So I'm going to keep the 4a squared. What's my numerator going to be? 18a. Just 18a. Okay, when we add, we don't change the exponents on those variables. Okay, that's only when we multiply. Good. Is this my final answer? No, it's not. What do I need to do? Simplify it. Okay, we'll start with just the numbers. 18 divided by 4. What will that simplify to? Give me a second. Okay, 18/4. What will that simplify to?
9/2a squared.
Okay, so 9/2. Yep, and then a over a squared. What will my a's do? So if I have 1a on top and 2 a's on bottom, yep, perfect. It would just be an a to the negative first, but we have to put that on bottom to keep it positive. Okay, is everybody good on how we do that? Does that make sense? I think in like algebra 1 they called that moving it to the basement, if you've heard that, right? So if it's negative, you've got to move it to the other side of the fraction. And that's your answer. Okay, so I want you to go ahead and do 2, 3, and 4. All right, due to time constraints, I'm going to go ahead and get started on these. So number 2, are my denominators the exact same?
Yes.
Yes, they are. Perfect. Okay, so I keep that same denominator. On the top, what operation's going on here? Subtraction. Okay, so if I just have 9x plus 12 minus 7x plus 2. What do I need to remember here that I'm forgetting? If I'm subtracting that whole numerator, what do you think I need? Parentheses. Yep. Okay, because we're subtracting that whole numerator. You with me? Okay, so if I have a negative in front of parentheses, what does that mean to do? Yep, distribute it out, right? It's the same thing as like a -1, so it's got to go to both. So this is actually going to be 9x plus 12 minus 7x minus 2 over 16. Combine like terms on top. What is 9x minus 7x? 2x. And what is 12 minus 2? 10. Okay. If you stopped right there, you would get most of your points, but you'd probably miss maybe 1 point or a half point. What else can I do here? Does anybody see it? Is this fully factored? Is there any other GCFs I could pull out, possibly? On the top? I could pull out a 2 on the top. I sure could. And when I do that, what's left? X plus 5. So 2 times x plus 5 over 16. Will that simplify further?
Yeah.
You do
the 2 and the 16.
The 2 and the 16, you sure can. And what will that become? Yep, 1 over 8. So this is actually the same thing as just x plus 5 over 8. So always, whenever you get to the point where you think you've got an answer, still check it, okay, and make sure that you have factored it completely. Because again, if you made it this far, you would still get most of your points. But to get all of them, you need to make sure you simplify completely, okay? Questions on that? Anybody get that one? Cool. Awesome. All right, number 3. Are my denominators the exact same? Yep, they sure are. Okay. Am I adding or subtracting? Adding, so that makes it quite a bit easier, right? I don't have to distribute out a negative. So I will keep my same denominator. On the top, I'm just going to go ahead and combine like terms with my numerators. Does y squared have any other like terms? No. 8y?
Yeah, 2y.
2y, what is 8y plus 2y?
10y.
Cool. And then just plus 21? Yeah? Alright. Now what? You can do the x method on the top. Okay, we'll try it. What goes on top? 21. What goes on bottom? 10. So think of 2 things that will multiply to give you 21 and add to give you 10. 7 and 3. Good. What's my leading coefficient on that numerator? 1. So will my shortcut work? Yes. So what will my factors become on the top? Was it negative? Plus 7. Good. So keep their same signs. Good. And then on the bottom, y squared minus 9. Just at first glance, that might not look like it's going to factor. But if we investigate a little bit, what is that? Difference of squares. Good. Good, good, good. Okay, so it's 2 terms. They both have to be perfect squares, and there needs to be a subtraction sign. Do we have all 3 of those things? We sure do. Okay, so what will this break down to? If I square root both terms, y minus 3 and y plus 3, in whichever order. Good. Anything going to simplify on this? The y plus 3s are going to cross right off. And I'm going to be left with just y plus 7 over y minus 3. Will that simplify further? No, it will not. Okay, I've got 2 binomials. They're completely factored, and they're not the exact same. So do not try to cross them off. Cool. Questions on that? Anybody get that one completely? No? Okay. All right. Number 4 is going to work pretty similar to number 3, so I'm going to give you a little more time to do that. And then go ahead and try 5 and 6 as well. Okay, make sure that we simplify completely. Number 4, common denominator. Do we already have it? We sure do. What is it? And what's going to be on top? There we go. Okay. 1 minus 16a squared. Will that simplify further? Yes. Do they have a GCF first off? No GCF, but can't I do what?
You can square root them, can't you?
Yeah, I can square root them. What do we call that? Difference of squares. We have a subtraction sign. We have 2 perfect squares, right? So I can square root them. And what will this break down to on top? We'll start with just the square root of 1. What is that? 1. And what is the square root of 16a squared? 4a. Okay, so I need 1 that's going to be subtracting those 2, and 1 that's going to be adding them, correct? So 1 minus 4a, 1 plus 4a. Questions on how we did that? Okay, on the bottom, 12a minus 3, do those have a GCF? 3. When I take that out, what do I have?
4a minus 1.
4a minus 1. Cool. Anything going to cancel?
1 minus 4a, 4a minus 1.
Yes, perfect. And what rule tells us we can do that? Yep, the -1 rule. So I've got to put a -1 out front. Okay, so my final answer is just going to be -1 times 1 plus 4a over 3. Good. If you wanted to simplify that down further by distributing out that -1, you could, but I wouldn't count points off for that. I don't think Mr. Millard would either. Okay? We'll keep going. Any questions on that? Okay. Number 5, is my common denominator already there? It sure is. Okay, so if we look on the top, what are we doing? Subtracting, okay, which means that I need to use parentheses on the second one. Okay, so this becomes n squared plus 3n minus 7 minus n minus 1. Combine like terms. Does n squared have anything on top? No. 3n. The -n, right? What's that going to be? 2n. And then -7 minus 1. Yep. How will I simplify this now? We'll start with the top. What do we call that? It's a trinomial, which means I need to try the x method. Yes. On the top, I have -8. On the bottom, I have 2 things that will multiply to give me -8 and add to give me 2.
-2.
-2 and 4. Good. So on the top, I now have n minus 2, n plus 4. And on the bottom, another x method, right? So on the top, we'll put -6. On the bottom, we'll put 1. 2 things that will multiply to give me -6, add to give me 1. Three and -2. Good. So over n plus 3 times n minus 2. And what's going to cancel? The n minus 2's, which leaves me with what? Perfection. N plus 4 over n plus 3. That's my final answer, correct? Because those are 2 binomials that are not the same. so they cannot be simplified. All right, we're going to go ahead and skip number 6, just because I feel like we've got the hang of this for now. Next up, we've got unlike base examples. Okay, so this was kind of what we talked about in the beginning. Okay, when the denominators are not the same and we're adding or subtracting, we've got to find that common denominator. Okay, so if we start off on number 7, look at those two denominators. We have 2x and 3x. So we'll start with just the coefficients, so 2 and 3. What is a number that they will both go into? 6, good. So what I'm going to do is I'm going to go ahead and, whoops, just write that 6 there. What about x and x? What will they both go into? X, good. So that is going to be my common denominator. But if I look, does 2x equal 6x? Obviously not. What will multiply, or what do I need to multiply by to get me to 6x? Just 3, right? So if I multiply on the bottom by 3, what do I need to do on the top? Multiply by 3. So what is 15 times 3? 45. Okay, now my second fraction. We've got 3x here, correct? What do I need to multiply by to give me 6x? 2. So I'll multiply by 2 on the top as well. 16 times 2 is 32. And I'm subtracting, so I'm going to put a minus sign between those two values. And what is 45 minus 32? 13 over. Will 13 over 6 simplify? No. So we're done. Questions on that? Okay. Number 8, I want you to just go ahead and find the common denominator, okay? And then try that one. At least try to get the common denominator. All right, what's my common denominator going to be? (8a squared). Raise your hand if you agree with that. Anybody get anything different? Okay, I would agree. So our coefficients are 1 and 8. They both go into 8. A squared and a will both go into a squared. Okay, so what I'm going to do is I'm just going to go ahead and write this common denominator twice. This is another way. If we need to write everything out, we can. So we'll start off with the first fraction, 4a over a squared. How do I get a squared to become 8a squared? What is it missing? The 8. So I just need to multiply by 8. So what is 4a times 8? 32a. Okay, now we look. 8a to 8a squared. What is that missing? Just a. So we're just going to multiply by a. What is 7 times a? 7a. You with me? Okay. 32a minus 7a over 8a squared. What is 32a minus 7a? What did we say? 32 minus 7 is what? 25a over 8a squared. Will 25 over 8 simplify? No, but what about a over a squared? Will that simplify? Yeah. What will happen there? Just an a on the top or the bottom? Bottom, good. So 25 over 8a is going to be my final answer. How are we feeling on this? 1 to 5. 3. Okay. Couple 5s, couple 4s. Is anybody at like a 1 or a 2? Okay, cool. Okay, we're just going to go ahead and start with number 10, actually. We're going to skip number 9 for right now. If I look at this, 7 over y plus 8 plus 35 over y squared plus 11y plus 24. This one's not quite as obvious what the common denominator is going to be, is it? No, it's sure not. Okay? Here's what we have to do when it's not obvious. We've got to factor first. Okay, we don't have to worry about the numerators right now, just the denominators. So if I look, my first denominator is y plus 8. Is that fully factored? Yes. What about the second denominator? What should we try? X method. Okay, so that's what we're going to do here. I'm going to go draw my X. What goes on top? What goes on bottom? Two things that will multiply to 24 and add to 11. 8 and 3. So my two factors would become on this. Just going to put a line through it. Y. Perfect. Okay. Now looking at these two denominators. What is a common denominator that will fully absorb y plus 8 and y plus 8 times y plus 3?
Can't you just add a y plus 3?
Yep. So my common denominator is just going to be y plus 8, y plus 3. Okay. And I'll go ahead and just write it for both fractions. We'll just go ahead and keep them broken apart for now. So we'll start with the first fraction. We just have y plus 8 as our denominator, correct? What are we missing? The y plus 3. So we're going to multiply 7 times y plus 3. Yep, we will distribute. And then the second one, 35 over y plus 8 times y plus 3. Is that missing anything from the common denominator? No. No. So do I need to multiply by anything? No. No, I don't. I'll just leave it as 35. Okay, now we can distribute and we can simplify. So what we have here, 7y plus, what's 7 times 3? 21 plus 35 over that common denominator. On top, what is 21 and 35 combined to?
56.
Okay, so we now have 7y plus 56 over our common denominator. Once you get good at these, you won't have to write out so many steps. But looking at the top now, is that fully factored? 7y plus 56? Probably not. What do they have in common? 7. And what does that become? 7 times y plus 8. Anybody see something that's going to happen here? The y plus 8s are going to cancel, and I'm left with 7 over y plus 3. Questions on that? Okay. I want you to go ahead and do number 11. It works very similar to this one. So go ahead and try that. All right, so looking at number 11. What do we do first? X method on the bottom, right? That first numerator, first denominator. What goes on top? What goes on bottom? 5, two things that will multiply to 6 that will add to 5. 3 and 2. Okay, so this first denominator now becomes what? Good. And what is the common denominator going to be between these two fractions? X plus 3 and x plus 2, right? Good. My first fraction. What is my denominator missing, or is it missing anything to get to the common denominator? The first one? Is this missing anything? No, it's not. Okay, so I can just keep its numerator the same, right? What about the second one? It's missing x plus 3, so I need to multiply, right? 1 times x plus 3. It's just going to be x plus 3. Okay, so now we just add straight across. So we've got x squared plus x minus 2, right? Everybody see what I'm doing here? Hopefully you already got it down. Is this fully factored? No. What do I need to do on the top? X method. So we start off with -2 and 1, two things that will multiply to -2 that will add to 1. What was that? -1 and +2. Good. So on top, what I have is x minus 1, x plus 2, over x plus 3 times x plus 2. What's going to happen here? Cancel out the x plus 2's. Good. And what do we have left? Just x minus 1 over x plus 3. Good. Questions on that? Anybody super confused? How are we feeling? We all right? Okay, cool. What we're going to do now, we're going to scroll down. We're going to do 14 together, and then I'm going to have you guys try 13, 15, 16. We'll go over them quickly, and we'll be done for the day. Okay? So we're going to skip to 14 together. If I look, I've got b plus 3, and I have b. Okay, so I need something that both of these will go into.
Plus 3.
Will b go into b plus 3, though? Evenly? No. Think about whenever we had those fractions from the beginning. Like, for instance, we had 3/4 and 1/3. We said our common denominator was what? 12, right? Couldn't we just do 4 times 3 to get that 12? Isn't every single one it will work as a common denominator if I just multiply both denominators together? Are you with me? Yeah? So if they're not common, I can just multiply both of them together, meaning that b times b plus 3 could be my common denominator. Yeah? Okay, that's how these are going to work. So if you can't see a common denominator, you can just multiply both denominators together, and that's always going to work. Won't always be the simplest, but when you can't find another one, it will be. Okay, so b times b plus 3 is going to be that common denominator. If I look on my first one, it's missing just the b, so I just need to do b times b, which is b squared, okay? And then my second one, it's got b, but it's missing b plus 3, so I need to multiply that -4 times b plus 3, right? On this one, I'm going to distribute out the -4, so I'll have b squared minus 4b minus 12 over b times b plus 3. On the top, I know I've got a trinomial there, which means I need to try the x method. I'll put -12 on top. On the bottom, I'll put -4. Two things that'll multiply to give me -12 that will add to give me -4. -6 and +2. Good. Okay. If we look now, we've got b minus 6 and b plus 2, right? over b times b plus 3. Is this going to simplify any further? I was gonna say that didn't look right. What'd you say? Do b what? Yeah, we need to have a 3 in there. Whoops. So we could use 3 in what? Why is that not working? Okay, sometimes you will have that, all right? Sometimes you will have it where it won't simplify, but it is always good to go back and check and just make sure, okay? So that's to go ahead and try. Let's just do, well, you guys have enough time to do your homework too. So let's just do number,
16.
that works. We'll just do number 16. All right, number 16. If we look at the very first denominator, what's that going to factor down to? Because again, we completely factor them before we decide what our common denominator is. So if I look, is there a GCF on 2r plus 8? 2. What does it become? 2 times?
2 times r plus 4.
Thank you. 2 times r plus 4. Okay. My other denominator, r squared plus 4r. What about that? R. And it becomes r plus 4. Okay. So I need a common denominator that will have both of these things in common. Okay, something that will absorb all of that. So if I look, they both have r plus 4, right? Okay, so I know that's probably going to be in my common denominator. And then 2 and r. What will 2 and r both go into? 2r. So let's just do 2r times r plus 4. Wouldn't you agree? That'd be a good one? Okay, cool. So I'm going to write it out twice. Eventually you'll get to where you do these fast and you'll write it out one time, okay? But we'll keep these separate for now. Looking at the first one, we just have 2 times r plus 4 as our denominator. What is it missing? It's got a 2 already. Just the r, right? So that's all I need to multiply that numerator by. What is r times r? R squared. Okay? Second one, what is it missing? Just the 2. So I just need to multiply that numerator by 2. What is 8 times 2? 16. Cool. So I now have r squared minus 16 over 2r times r plus 4. I know that the bottom is fully factored, but what about the top?
Perfect square.
Perfect square. Good. Difference of squares is what we call that. What will that break down to? Perfect. R minus 4, r plus 4 over 2r times r plus 4. What's going to cross off here? R plus 4. And we're left with just r minus 4 over 2r. Will that simplify? No. Okay. If they're both fully factored, the numerator and denominator, a binomial and a monomial will not simplify. So please don't try to do that. Okay? Cool. Questions for me today? All right. I know this was long, but it's just a big concept. Okay? We got to get this down.